And here we're gonna start about the word logic operation right here. And first thing will be the AND gate. So I'm placing the AND gate right here. So just want to change it to word or double word. I'm using the word, and in one and in two. The AND gate, it is 2 inputs digital and 1 input digital output. So if you want to know about the AND gate, I'll draw it, the AND gate tutorial, and you can see this will be the digital logic and AND gate symbol looks like. And this is 2 inputs, A and B, and here is the output. So if the both of the inputs are on, we get the output on. That is the digital AND gate. So like the truth table will be go like this: A, B and O. Due to digital and 2 inputs, we'll be getting 4 combinations. A and B, both of them will be 0. One will be 1 and the other will be 0. One will be 0 and the other will be 1, and both of them should be on. And we are only getting the output at the 1-1 condition. That is the AND gate. So here 1, the rest of the outputs are 0, 0 and 0. So this is our output. That is the AND gate. So we can consider this as an word logic AND gate. I am putting this input as MW0, and the second thing as input 2 as MW2, and going to the output as MW4. So that's it. So we just gone through MW0, 2 and 4 for the 2 inputs and 1 output in the AND gate. So we can run this thing. And we are at the runtime, and we may not be able to see anything in this block, only in the boolean things only. So we can go for the simulation mode and check. You can close the input and output and go for the memories. Insert bit memory 1, 2 and 3. So 3-bit memories. The AND gate means I'm using 3-bit memories. That first 2 will be the input MW0 and MW2. So I'm using MW0, and here I am using MW2. Okay, and here I am getting the result in MW4. So I'm using MW4. That's it. Everything should be in the integer format, sorry, in the binary format. So binary here also binary, and here also binary. So the AND gate means 2 inputs should be on for getting the output, like I can draw in the paint. 1 1, we getting the output 1. So as a word or a word operation, you can see making the first one as 1 here. Here I'm using 1, and we are not getting any output right here. This is the output, and I'm making the corresponding 1 to the second input as 1. So here also 1, and now we are getting 1. 1 1, we are getting 1 here. So you can see here I'm using 1 1 1 1, 4 ones right here, and no output right here, and I'm using 1 0 1 1. And see, wherever there is 1 in both inputs, we getting the outputs on the MW4. That is the word logic for the AND gate. Like that, corresponding things we are going to the OR gate and the XOR gate. It is very simple, OR and XOR. So it's changing it to OR. You can see the operations. OR means if any one of the input is activated, we get the output. That is the OR gate operation. And if any one of that means that could be 0 0, no output, and 1 0. Let me draw in it in another paint. So OR will be looks like this. Okay, A and B, and here we getting the output, and A, B and O. OR condition means 0 0, we are not getting any output. 0 1, we will get the output because B is present here. 1 and 0, we will get the output. That means A is present here. 1 and 1, also we get the output. That means all the other conditions except the 0 0, we will be getting the output. That is the OR condition. A or B, we gets the output on. That's it. So we can go for the runtime. And you can see Okay, in this current condition you can see if any one of these activated 1 1 1, and you can see 1 1 1, and here you can see 1 1 1 0 1 1. Here you can see the 4 ones, and here you can see 3 ones, but in the result we are getting all the ones, because if any one of the 1 is present we get the output. Here I am making it as 1, and we got the output right here, because any one of this present input is present, we get the output. That's it. So we can actually go for the last one, that will be the XOR gate. The XOR means, see, I'm just using the XOR. XOR means exclusive OR. Exclusive OR means if there comes with a different input, we get the output. That's it. That means 1 and 0 we get the output, 0 and 1 we get the output. At 1 and 1 or 0 and 0 we are not getting the output. Let me clarify that for you. So A for XOR, A, B, O. So this will be the truth table. 0 0 no output, 0 1 we get the output, 1 and 0 we get the output, even 1 and 1 we are not getting any output. Only in the condition at the different inputs we are getting the output. That is the XOR gate. Okay, XOR or the exclusive OR. So we can see only at the different condition. That means here you can see 0 and 1 we are getting the output. At 1 and 1 we are not getting the output. Only in the different condition. Even if it is 1 and 1 we are not getting any output. 0 and 1 we get the output, or 1 and 0 we get the output, like this. See, 1 and 0 here we get the output on the MW4. That is the XOR gate. Now we can go for the one more thing, that is the invert block. So I'm changing it to the invert. So simply placing the invert. Invert means inverting whatever in the input is. So integer, this will be MW0 and MW2. So whatever is the MW0, that will be inverting to MW2. Let's see. So you can see in the picture, whatever is in the MW0, that will be inverted to MW2. We don't need the MW4 right here. Only one input and one output. See, you can see 1 is inverted to 0 here. The other 3 zeros are inverted to 1 here. Whatever there is 1, that will be inverting to zeros. Whatever there is zeros, that will be inverting to ones. That is the inversion block. So hope you understand these kind of word logic operations. Now let's go to the next thing, that will be shift and rotation operations.